So in the last section, we started talking about significant figures. It's important to remember that significant figures only apply to measurements, to numbers that we've actually measured. Now, significant figures are limited by the accuracy of our measuring tool, which is important because then when we do calculations involving a measurement, we can't suddenly say that our measuring tool is more accurate than it was. If my measuring tool only gave me 3 significant figures and I perform a calculation with it, and then suddenly I just spit out what the calculator told me, then I'm saying my measuring tool was a lot more accurate than it was. And that's dangerous. So we want to make sure we know how to round our answers when we calculate so that we have the correct number of significant figures. Okay? So if I'm multiplying or dividing, then what I need to do is I need to look at the numbers that I'm multiplying or dividing, and the number of significant figures in my answer is going to be the same as the number of significant figures in the least precise measurement. Okay? So I've got this example below. 4.56 has 3 sig figs. 1.4 has 2 sig figs. Now because this one has less number of sig figs, it's going to limit my answer. So when I plug this in the calculator, it'll say 6.38, but I can only keep 2 significant figures the same as the number in the least precise measurement. So I go 1, 2, and I'm going to cut it off there. Now when I round, I only look at the number directly next to where I cut it off. If it's higher than 5 or higher, I round up. If it's 4 or lower, I leave my number alone. Since this is an 8, I round this 3 up, and my answer becomes 6.4. It now only has 2 significant figures. Okay? So for addition or subtraction, it's going to be a little bit different. What I'm going to do is I'm going to be looking at numbers after the decimal in the least precise measurement. Okay? So unlike addition or subtraction, where I'm looking at sig figs, here I only care about decimal places. So 12.11 has 2 numbers after the decimal, 1, 1. 18.0 has 1 number after the decimal place. 1.013 has 3 numbers after the decimal place. Now again, I'm going with my smallest number, which is 1. So when I add this all up, I get 31.123. I can only keep 1 number after the decimal, so 1 number after the decimal, I cut it off there. Again, I only look at the number directly next to where I cut it off, which is a 2. Because it's a 2, I leave this one alone, so it rounds to 31.1. Okay? Again, this is only true for numbers that are based off of measurements. Okay? Now let's say I had to add something and then multiply something and divide something, and I've got a whole bunch of calculations I want to do. I'm not going to round my answer until I've done everything. So once I get to the end, then I'm going to round my answer. Okay? Dimensional analysis is a big fancy term for changing one unit into another. So what I'm going to do is I'm going to be looking at units of measurement and changing them into different units of measurement. This is one of the most helpful skills that you're going to have throughout this class, so you want to make sure that you're really good with this. So here I've got my equivalence statements. Now remember, equivalent is equal. So 1 meter is equal to 1.094 yards. These are exact numbers. They are not measurements. They do not limit the correct number of sig figs in my answer. Okay? So I'm told that a pencil is 7 inches long. I want to find its length in centimeters. So I've got 7.00 inches. I always start with the number that's given to me in the problem. I'm going to draw a time sign and a line. Now I want inches to go away. Whatever units I start with here, I want to go on the bottom so that they'll cancel out. So my units here always have to go on the bottom. Whatever units I'm changing to have to go on top. Okay? So now what I'm going to do is I'm going to look over to my equivalence statements. Over here, I need to find something that has inches and centimeters. Well, if I look here, I know that 1 inch, so I'm going to put a 1 next to my inch, is equal to 2.54 centimeters. So I put 2.54 next to centimeters. Okay? Now, when numbers are on top, we multiply them. When numbers are on bottom, we divide them. So I'm going to take 7.00 times 2.54. I'm going to take that answer and divide by 1. Any number divided by 1 is going to stay the same. So when I plug this into my calculator, I'll just do 7.00 times 2.54, and I get 17.78. Okay? Now, when I look at this number, I need to round based on sig figs. I multiplied and divided, so I need to look for my number that has the least number of sig figs. Now remember, I want to only look at measurements. These are not measurements. This one is. So the pencil had 7.00 inches. When it has a decimal point present, I start on the Pacific side, first non-zero number, 1, 2, 3 sig figs. So my answer can only have 3 sig figs. 1, 2, 3. I'm going to cut it off there. Because the 8 is a 5 or higher, I'm going to round up. So my answer is going to be 17.8. I have to keep track of my units. My inches cancel out. I'm left with 17.8 centimeters. Okay? So here, in example 2, I'm told a pin measures 2.85 centimeters in length. So I start with my given number. I draw my time sign and my line. Because I'm starting with centimeters, I want centimeters to go away, so they go on the bottom. Okay? What is its length in inches? The unit that I'm changing to goes on top. Okay? Now again, I need an equivalent statement that has centimeters and inches. So I look over here. 2.54 centimeters, because the 2.54 is next to centimeters. I put that there. Is equal to 1 inch, because the 1 is by inches. I put that there. When numbers are on top, we multiply. 2.85 times 1, any number times times 1 is itself. Numbers are on bottom, we divide. So 2.85 divided by 2.54. When I plug that into my calculator, it tells me 1.122047. Well, if I keep all of that, it's way, way too precise. My measuring tool wasn't that precise. My measuring tool only gave me 3 sig figs. So my answer can only have 3 sig figs. 1, 2, 3. because this is a 2, it stays the same, so I would round this to 1.12. This time, my centimeters canceled out, and I'm left with inches. So take a second, solve example 3. Example 3, you're told that you have a 25.5 inch frame for a bicycle, and you need to find out how many centimeters the bicycle is. So take a second, use your equivalent statements above to figure out how many centimeters the bicycle is. Make sure that you round your answer to the correct number of significant figures. Make sure that you have correct units.